So this ship captain at sea uses a sextant to cite an angle of elevation of 37 degrees to the top of the lighthouse. So drawing the picture is still an issue. So you've got someone on a ship. That's going to be my ship. And there's a lighthouse, which is going to be here. And the ship is some distance from the lighthouse, and the angle of elevation to the top is 37. So angle of elevation is always from the bottom looking up. That's 37. So far, so good? And the lighthouse to the ground, a tree to the ground, anything, a building to a ground, that's always assumed to be a right angle, right? Unless we're talking about the Leaning Tower of Pisa. Okay. After the ship travels 250 feet directly towards the lighthouse. So if this travels 250 feet towards the lighthouse, let's say it puts you there, then that's going to be 250, that little section. I'm going to go capital S for ship. Right? We're going towards the lighthouse, 250 feet. Now the new angle of elevation from that new location to the top of the lighthouse is now 50. Does that make sense? Okay. The ship's charts show that there are dangerous rocks 100 feet from the base of the lighthouse. So here's the base of the lighthouse. 100 feet this way, and this, I hate this problem. I should have started with the other one because this one is made more complex. So apparently there's rocks here, and they want to know how far is this section? How far is the boat now from the rocks? So I'm going to call this X. That's what they're looking for. Find the nearest foot. How close to the rocks the ship is at the time of the second sighting. So on Friday, I had you guys try to use, what did I do? So I had you take this, and I had you work exclusively in this triangle with the law of sines, which if you know this angle from the supplement, then you know this angle. So you'd have opposite angle, opposite side. And then I had you do opposite angle, opposite side. And we actually could have done this one on there. And then when you know this side, then you can just focus probably on the adjacent over hypotenuse because you would know the side. So you could do it that way still. But when I looked at this, I had a different idea. So let me show you this. I can work in my right triangles twice. This is another option. I can do an equation within this right triangle and within this right triangle because they share the lighthouse, right? So I'm going to call that Y. And I'm going to set up two different SOHCAHTOA problems, one for the small right triangle and one for the big right triangle. So the way I'm teaching it right now is to not use this non-right triangle at all. Versus on Friday, I did use that doing the law of sines. So if I set up something from the smaller right triangle, I would do opposite over adjacent, so that would be tangent of 50 equals y over, and the adjacent here, how would I describe that length? X plus 100. If I then go to my bigger right triangle, to the 37-degree angle, my opposite is still y. What's my adjacent? Does everyone see that? 350 plus x, the 250, the 100, and the x. So for a second equation, I would do tangent of 37 equals opposite y over adjacent 350 plus x. So this is maybe a little more complex. I don't know. It kind of depends on how you feel about being comfortable doing the law of sines in this one like we did on Friday. But because this one, the downside is it's a system of equations. There's two equations, one with y and x, a second with y and x. So what you can do is you can solve both equations for y. So to get y all by itself and to undo this division, I have to multiply both sides by x plus 100. So tangent of 50 times x plus 100 will equal y. Is just me rewriting that formula. And then to get y all by itself here, I would multiply both sides by 350 plus x. Oops. Tan of 37 times 350 plus x will equal y. And then when they both equal y, you can set them equal to each other. Follow? So tan of 50 times x plus 100 gets set equal to the tangent of 37. And this from here wouldn't be bad to solve if the tangent of 50 was a whole number, or the tangent of 37 was a whole number, but it's not. So unfortunately you have to, and we're just going to distribute the tan of 50. So that'll be tan of 50 x plus tan of 50 times 100. I have to go to degrees. (119.2), and then tan of 37 times 350 gives me 263.7 plus tan of 37 times x. I'm just going to keep tan of 37 times x. So now to oh yeah, because I know what's that? I'm going to get all my x's on the same side. Yeah, but it's like tan of 50 minus tan of 37 isn't going to be like tan of 13 though. So do you like the way on Friday better? Yeah. Well, I didn't teach you this way on Friday because I figured, well, yes there was. We could have solved it this way on Friday. I gave you the law of sines way. Right, you've had it where you had to find this whole thing. That's really not making a big, that's not the issue that you're having now. It is, it does add an additional element, but that's not the part that you're worried about. So you don't like the system of equations. Alyssa, you felt like you were fine with it. Well, like, because I called the whole thing y. But that's kind of what Tommy's talking about. That's not what's causing the issue. You don't like the system of equations method? It's longer. It is longer. So let me finish this out. So I'm just going to subtract my 119. You don't have to necessarily write it, but I'm going to subtract my 119.2 from this side, and I'm going to subtract my tan 37 times x from the left side. So my right side becomes 263.7 minus 119.2. Keep in mind I rounded those numbers, so it's a little bit dangerous, but just for the sake of getting through it. That'll be my numbers on the right. Then on my left, kind of this is where I was telling you, tan of 50 minus tan of 37. That's a number and that's a number, but it's not going to be the tan of 13. So you just have to type in tan of 50 minus tan of 37, and that's how many x's you have, 0.438. And then just divide both sides by 0.438 and you're done. So 114.5 divided by 0.438 gives you in the ballpark of 329.7, which is 330. And that's your answer. You don't like the system. So then when I show you the second one, I'm going to show you the way and reinforce the way that I taught you on Friday. This would be the only option. Would be to create a system of equations with the two right triangles specifically. So here's your options. It's either a law of sines with this triangle followed by a SOHCAHTOA with that triangle, or it's a SOHCAHTOA with both, but then there's a system involved. I did say that too, but now that I'm looking at it, I think it's fine either way. So let me do this one just to be sure. I'll do this one the old way. I'll set it up. I'm not going to go through it the whole way. So we're sailing in a boat. We see a lighthouse, right? Angle of elevation is 3. So that's 3 degrees. We sail 700 feet closer. And now our angle of elevation is 5. Are we good with the diagram? Okay. So the way on Friday what I did was to do a law of sines with this one to give us the hypotenuse of the right. So the way we would do the law of sines is if this is 5, what's this? 175. And if this is 175 and this is 3, what's this? 2. So your law of sines would be 700 over the sine of 2. And we want to get the hypotenuse of the right triangle. So we're going to do some x value over the sine of, wait a minute, 85. So 2 is opposite 700. X is opposite 3. Yes, because I want to get the hypotenuse of the right triangle. So then sine of 3. So when you cross multiply here, so just 700 times the sine of 3, and then divide by the sine of 2. I'm not showing my cross multiply work, but X would be 1049.7. And once you have that, now we can fully focus in the right triangle. They want to know how tall is this, so I'll call that Y. And so we have the 5-degree angle. They're asking for the opposite, and we just figured out the hypotenuse. So opposite and hypotenuse means we need to use the sine, cosine, or tangent. Sine. So the sine of 5 you could do x, now that you know this, you could do 1049.7 over the sine of 90 equals y over the sine of 5. Yes, you could. Yeah. Most people prefer SOHCAHTOA. But if you want to do law of sines twice, this is the trouble. When there's options for kids, it's not ever a good thing. Turn your music down. And take your headphones out. Okay. So Allie, if you want to do that, that's fine. Sine of 5 for... Yeah. Because you're looking for what they asked for y. I'm just going to do sine of 5 equals the opposite y over the hypotenuse 1049.7. Most people think SOHCAHTOA is quicker. So... Yeah. So if you don't like the system of equations way, then forget about what I said at the beginning. Oh, you're right. What'd you say? Andrew? I know. You need to be sensitive to that this day, okay? All right. Now, the rest of this, that's your force type question, no twists. That's your area type question. There's really no twists with anything else, I don't think, although 5. Yeah, I'll set 5 up, and once I set it up, you'll see it. Yeah. It's a tough one. Okay. So in 5, to draw the diagram, you're from point A on the edge of a river. So this is just going to be my river. River. And this is my point A. And the measure of the angle of elevation to the top, gentlemen, enough. The angle of elevation of the top of a tree on the opposite bank is 37. So here's some tree, and the angle of elevation is 37. You follow that, Allie? Okay. And then this is where the wording gets a little bit funny because they're trying to explain something that would be so much easier if they just showed you. But from point B that is 50 feet from the edge of the river and in line with point A, so this point B is just in line with point A, it's just 50 feet further out. It's further off the edge of the river. It's 50 feet. Yeah, I agree. I don't love the only other way, because they said it was in line with A, were you going down for, like it? Oh, you were going that way. 50 feet, yeah. So this is what their intention was. If I'll be mindful to try to avoid the confusing word problems on your test. But from that point, the angle of elevation is 22, and now it's the same as the other ones from above. Same diagram. Are you good? Okay. All right, pass that forward. I wouldn't have said that because I didn't know what we were going to do this year. Andrew, I don't believe you one bit. I wouldn't have said that because I legitimately didn't know what I was going to be doing with you this year. I'm just following orders. They're not really orders. I'm following suggestions. I could do basic addition with you, I suppose, if I wanted to, but I think that would be frowned upon. Because my job is to teach you things that you don't already know. Did you need, Maddie, did you need a Spyro? Here. Oh, okay, good. Oh, it is there, but it's like in the beginning of the chapter. There's a link for all of them, and you would have had to sift through and find it. Okay.
Yeah, we have 4 minutes.
Ah.
Yeah, looks like that word that he Good job. Good work. Good work, boys.
All right, here's the trade-off. What's that? No, I'm not going to give you homework. You are going to have a quiz on one of these tomorrow. Not those exact problems, but that tomorrow. One question on that type. Okay?
The whole area is made up by a triple.